So today we're making a modular combat system. This is mostly meant for melee combat, but you should be able to use this in a slightly modified version to add like ranged and magic attacks as well. So what we have here is an array of attack assets. So as you can see, my combo consists of sword attack 1, 2, then 1 again, then 2 again, and then 3. So this is my entire combo. In terms of gameplay, that looks like 1, 2, 1, 2, 3. And if I want to change that, it's as easy as just changing around some of these assets, maybe adding a couple of slots, taking a couple of slots away, and it's very easy to change and iterate, even during gameplay on this. So I'm here in a template project that I've made for a different combat system. We're going to improve that. I've deleted all the existing combat code from my previous projects, and if you want to see the finished project with the modular combat system, there's a link down below in the description to my Patreon where you can get the full project files, including these models and animations that we're going to be using. So I have a sword here, which has a quick little script on it, and that script has a weapon name, which we're actually not going to be using anymore either. We've got a damage variable, which we're actually going to set to being public. A combo length, which is going to be not necessary anymore either. A box collider. And everything this script does is when it collides with an enemy, it deals damage to the enemy. And it's got two functions to enable and disable the box collider at the start and end of every single animation. Then we've got a player combat script, which I just made and entirely cleared out of any existing code. And this is what we're going to be using to actually make the combo system. Before we get to any of that though, we're going to need to make these scriptable objects so that we can have assets that have the information to go with our individual attacks. So let's make a new C# script and call it attack scriptable objects. Now, opening up that script, we can actually get rid of the start and update functions because we're going to change this from being a mono behavior to being a scriptable object. And since we have a scriptable object now, we can actually, above the class itself, we can add these brackets with create menu assets. And then in the parentheses, we can give it a menu name, which is a string. And here you can just give it whatever name you want. If you want to have a submenu, which I do, you start with the name of that submenu. In this case, that would be something like attacks. And then simply just put a slash and then the name of this specific asset. So that will be, for us, a normal attack. The scriptable object is going to hold a couple of pieces of information. You can expand this as much as you want. We're going to keep this relatively basic. So we're going to start by adding a public animator override controller. And we'll name that Animator OV. And then I also like to add a public float for the damage so that we can have individual damage for every single attack that we add, rather than it being based on purely the weapon class. In my own game, I also have a float for knockback. I have a variable for a visual effect, so that every single attack can have its own effects dedicated to it. And I've also got a string for an attack name, which that's all stuff that we're not going to do here, but do feel free for any functionality that might exist within your game to be added here on a per attack basis. It's a very flexible way of working. Now, coming back into Unity, we can actually right click, and when we go to create, we now have a submenu here called attacks, just as I predicted. And we can add a normal attack. So we have a scriptable object, let's call this just attack 1 for now, which holds two pieces of information, a animation overrider and a damage variable. Let's put the damage to 5 for our first attack, and put the attacks into a dedicated attack folder just to keep things a little neat. Now we're going to need to make a animator overrider controller. So we create a new asset, going all the way down here to animator override controller, and we'll also call that attack 1. This needs to know what controller is going to override. So we can go into the player folder here, and we've got the player animator controller, which is the thing that you're seeing here on the right. We can drag that in, and now we get all of the individual animation clips that exist within this controller, and we can put in new animation clips that will be played instead. So if we want to change the running animation for whatever reason, we could put in a different running animation here, and it would, whenever we trigger this Animator override controller, play that running animation instead of the original one. Of course, we want to have a different attack animation for every overrider controller that we make. So in the Animator that we have here, we're going to add a new empty state, and we're going to call that our attack state. This is the only attack state that we're ever going to add into our whole Animator system, because this state is going to get our individual animation clips for attack 1, 2, 3, 4, 5, 6, 7, however many you might have, inserted into it. We'll just put sword attack 1 in there as just a simple placeholder, and then from the attack we make a transition into the exit. The transition into the exit is going to be based on exit time, and I like to put that exit time quite high at 95%. In your attacking state, it's also a good idea to give it a tag. I just call the tag attack as well. You can call it whatever you want. And now if we go back to our animation override controller, you see sword attack 1 is now a replaceable clip. So we can go into our animations and drag that onto there. Well, right now we're replacing sword attack 1 with sword attack 1, which doesn't seem particularly useful. But what we can do is we can simply just copy this over a couple of times. So we can make one for attack number 2, and then one for attack number 3. And now it's as simple as just selecting attack 2, the overrider controller, and dragging in our second animation, and then selecting attack number 3 controller and dragging in our third animation, and so on and so forth, depending on how many animations you have. And in much the same way, we can just copy and paste this attack asset that we have. So we can call this attack 2 and this attack number 3. And then in every attack, we put in the corresponding overrider controller that we have made. And now these scriptable object assets that we have all have the information of how much damage they should do and which animation they should play. Let's put this one at 8 damage and this one at 10 damage, just to have a little bit of a difference. Now, finally, it's time to get into our player combat scripts. And here we're going to have to make a fair number of functions. The first and most complicated one is going to be our void attack function. This is going to house most of the actual functionality that we're going to be using. Then we also need a function that's called void exit attack. This just checks whether or not we're at the end of any of the attacking animations, so that we can then exit the combo. And exiting the combo we'll actually do in a separate function called end combo. And we're going to need a simple variable array here, or a list rather. So we're going to put in a public list of the type attack scriptable object, and we'll call this just our combo. Then we're going to need a float for our last clicked time. This will remember the game time at a moment where we last started an attack, so that you can't spam attacks too quickly after each other. Then we also want to use a float for our last combo end, which has a similar function, making sure that after you end the combo, there's a certain amount of time that needs to go by before you can start doing the next combo. And then we also want an integer for our combo counter to keep track of how far we are into the combo. Now it's time to start actually making the attack function. So we're going to start that with an if statement. We're going to check if time.time minus our last combo end is less than a certain amount of time between the combos. You can make this a variable as well if you want to change this around. We're going to go for 0.2 f to make sure that the engine knows that we're using a float. And then we'll check a second condition here with two ampersand signs. And that will be our combo counter being less than or equal to our combo.count. So if our combo counter is like 15, but our combo is just 4, that shouldn't ever be possible, but just in case it happens, this code will just not run. First and foremost, when we start an attack, we're going to cancel a invoke, and we're going to cancel any invoking of the end combo method. This will make a little bit more sense later on, because we're going to invoke this, but if we actually start a new combo between the time that we invoke that method and it actually getting invoked, things will get messed up. So we need to manually say, hey, if you plan on invoking this method, just stop doing that. We don't need to do that anymore. Then we're going to check another if statement, and that is if time.time minus our last click time is less than or equal to, and again, you could make this a variable, but a certain amount of time that needs to pass between being able to use attacks. So I'm going to use 0.2 for this as well. But these could totally be two separate things. You could say that, for instance, I want to have half a second between combos, but only 0.2 seconds between attacks. That is totally fair. Matter of fact, let's actually do that. Now, we're going to need a reference to our animator, which we can simply get from making an animator variable. So let's make a animator, which we just call anim, and give that a value in the start function of get components animator. It's as easy as that. So now it'll just look through the game object for an animator and put that value into this variable. We're going to check in that variable its runtime animator controller, and we're actually going to set that to the animator overrider controller that we have made. So that will be our combo, and the index of our array, or list in this case, will be our current combo counter. So if this is the 0th attack, so the first attack, index 0 of the array, it will look at the corresponding scriptable object and take that animation override controller. If it is the 3rd attack in our combo, for instance, it will look at the 3rd attack in the array and take that animation override controller. So from there we take our animator OV. Then in our animator, once that has been set, we use the play function, and we will play the attack state on layer 0 at a normalized time of 0. So it starts at the very beginning of the animation. Then, since our attack also has a damage value, which needs to be on the weapon, we actually need a serialized field reference to our current weapon. And we need to make sure that the damage here is a public variable. So then we can say our weapon.damage is equal to our combo. The index will be our combo counter.damage. This way our weapon will get set to whatever damage value we've gotten in the asset that we're using right now. And if you have things like a knockback or a visual effect or whatever, you do all of that right here in the code. After you have set every single variable that you need to set in your weapon or in your player, that might be in there for your specific gameplay purposes, you just simply add a combo counter ++ to increment it by 1. We set our last clicked time to time.time. Then to make sure we don't ever go past the length of how long our combo is, we put in an if statement where we simply check if increasing our combo counter has made it greater than our combo.count, because if that's the case, our combo counter is going to need to be reset to 0. That's the basic idea of how to trigger these combo animations. Now let's move on to the exit attack function, because this is actually relatively simple. We just put in an if statement where we check our animator and we get current animator state info of layer 0, and we check the normalized time being greater than 0.9. So that's checking whether or not the currently playing animation is further than 90% of the way done. Then we also check in our animator state info, so we can just copy this over to that side. But instead of the time, we'll actually check the isTag function. And there we put in the attack tag, or whatever you call your tag. This way, whatever code we put into the brackets here will only run when the currently playing animation is an animation that has this tag and is more than 90% of the way done. And if that is the case, we will invoke and combo. And the reason we use invoke is because it's very easy to say we want to invoke that after 1 second. This way, there is a little bit of leeway after the animation finishes to still do an input for doing the next attack in the animation. It just makes things feel a little smoother. And in here, we simply set our combo counter back to 0 because we're resetting the combo. We set our last combo end to being time.time. And whatever other things you might want to do at the very end of your combo. Like if you have a game where ending a combo always ends up with a explosion, for instance, you would put it in this function as well. Now, we put these functions into the update function. So we've got the attack and the exit attack. The exit attack will just be checked every frame, no matter what. But the actual attack itself, we're going to put a if statement for. And that is if inputs get button down. And I think the default is called fire1 for this. Then we will do the attack function. As you can see in the input manager here in your project settings, we have the axis called fire1, which is controlled through the left control or mouse 0 buttons. So when either of these is pressed, then that attack function will run. Now, back on our player object, we can go down into our player combat, and now we see we have a combo list to which we can add these individual attacks. So we've got this scriptable object that we made at the start of this tutorial, and I'll just do the same thing that I did in my own game, and that's attack 1, attack 2, attack 1, attack 2, and then attack 3. We also need to give it a reference to our weapon, which is on our sword. So let's drag that in as well. That way it can actually influence the damage that we're doing. And in theory, right now, we should be able to, as you can see, have a modular combat system. If you just do like 1 and wait a second, and we press 1 again, we just start to combo over. And we can do 1, 2, 3. We wait a second, and then we just start the combo from the start again. But if we do 1, 2, and we wait half a second, it picks up where we left off in the combo. So it's actually a pretty good, satisfying, and easily interchangeable combat system. Because we could very easily make a pickup here to, let's just actually very, very quickly do that. Just like make a cube, for instance. Make the collider a trigger. Add to combo script, and we'll get a serialized field for a attack scriptable object. And then on trigger enter, we can make a variable for player, which is equal to other get components player combat. Then we simply check if player is not equal to null. We go player.combo.add I needed to give this a name. We add our attack to that list, and then we destroy this game object. So now let's say we want to add attack number 1 to our combo. We'll be able to see that if we run this game now, and we take a look at our player combat, it's attack 1, 2, 1, 2, 3. But when we pick this up, you see another attack 1 is added to this. So on runtime, and you'll be able to see it adds another attack to our combo at the very end. Now, if you want to add an attack in the middle of your combo for whatever reason, that's going to get a little bit more tricky, but entirely possible. So yeah, there's a very, very flexible system for your combat to be based on. So if you like this video, don't forget to leave a like and subscribe. And if you want to check out the project or support the channel, you can always go down in the description and check out this project file linked in the Patreon link down below. And thanks to my patrons, you can see them on screen right now. And a special thank you to my Cave Digger tier Patreon, Syntax.